space and time, things about building out computational language for the world and so on. But today I'm here to do an NFT live minting, my first public NFT live minting. I should explain a little bit sort of how we got here and what we see the significance of this to be. And this is the beginning of kind of a large story, I think, something that we're planning a lot from. So I'm kind of interested in computation in all its forms, which means computation as done by computers, computation as done by the universe, computation on things like the blockchain, which is kind of an example of a permanent autonomous computation. And that makes it something different from what we tend to have seen before, and something which makes us think about different kinds of things. So I myself have built this sort of big stack of science and technology, kind of alternating between doing basic science and building technology. I would say that the things that we'll show today and we're doing today are the result of various pieces of science and various pieces of technology that I've been involved in, and lots of ambient technology that exists in the world. So I should also say that the things we're doing here will be very leading edge. So lots of stuff may fail, but that's what it's kind of a live streamed live minting. So my real personal objective here is to just understand more about this very interesting new form of computation that is blockchain and NFTs and all those kinds of things. It's what we're doing today is sort of a mixture of sort of future technology kinds of things, together with something else that I'm very interested in, which is storing history and the past and so on. And I suppose I spend some large part of my life building what one might think about as kind of artifacts from the future, so to speak. The challenge is always to have people understand in less than many decades what it is that one's built. But I'm also very interested in the past. I study history quite a bit. I think I'm still probably the human who's recorded the most stuff about themselves over the past third of a century in terms of personal analytics and so on. And so part of the thing, I wasn't quite sure what the significance of that was until I dived more into the basic science that we've done in terms of computation, in terms of physics and so on, to realize that in some sense, history is all we've got. Other than that, everything is kind of generic. So that's kind of a justification for my long-time personal interest in history and recording things. So, okay, that brings us to NFTs and live minting. I think the thing that I see as the most interesting is live minting, NFTs. It's all about something that happens now, something that's created now, but something that will be stored forever. And it's a very interesting thing about blockchain, that kind of the question of how do you store something forever, and why should you store something forever, and what's the motivation for the world to help you store something forever. Well, this is where blockchain is really interesting, because the way blockchain gets its strength is through the consistency of a ledger that just progressively builds up block after block. But in order to maintain that consistency, it's necessary that every brick, every block from the beginning still maintains its integrity. So in a sense, as blockchain continues to have value going into the future, it's necessary that those who contribute to it in the future maintain its past. It's something where, unlike in many places in the world or in the course of history and so on, where the future is fine and everybody's happy with it, this is a case in blockchain where you have to maintain the past in order to maintain the integrity of the present and the future. So that makes it an interesting place to store kind of the history of things. And I think that's kind of the concept here, is what one is doing when one puts something onto the blockchain, and one is putting something there that the future users of the blockchain are required, will necessarily store. So that's a very fundamental feature of blockchain and the concept of how it works. So it's something where there's no particular person in charge. It's just if there is this decentralized collection of people using a blockchain, it is necessary that they will maintain the integrity of what's already there. So it's a good way to store history for that reason. And in a sense, the sort of, one can think of the blockchain operating in the world as just sort of an autonomous computation that's happening on all those different nodes that store the blockchain and all the protocols that maintain consensus for what happens on the blockchain and so on. It's kind of an example of autonomous computation. It reminds me greatly of what we now understand happens in physics and in our universe, where we also have lots of autonomous computation just happening, maintaining our physical universe. It turns out there's an awful lot more computation maintaining our physical universe than maintaining the blockchain. Just to maintain the structure of space probably takes us 10 to the 120 times sort of everything that we currently see happening in the universe. So a lot more computation. I might say, by the way, and this is something I probably won't get into too much today, that understanding more about how space and time really work in physics has given me a quite different perspective, I think, on ways to imagine kind of the distribution of blockchain and the way that one stores information and makes things happen kind of at the level of blockchain. I suppose the difference between the universe and what we think about in blockchain and so on. In the universe, we have the code is fixed. The code of the universe is fixed. It's just doing what it's doing. That is our physical world. That's all we get. In the case of blockchain, we also get to add these computational contracts, these things which are in addition to sort of the base code, just as we might add a contract in the law that goes in addition to the basic code of law, so to speak. So similarly, we can do that for blockchain. We can add computational contracts, and they can do things which operate according to the underlying laws. It's just like kind of adding technology to the physical world. But it's something where, again, it will then operate according to those sort of fixed underlying laws of the blockchain. So sort of unlike in physics, we get to make these local rules, these sort of local computational contracts. All right, so to NFTs, just to explain what the point is for people who might not know. Sort of the typical idea on a blockchain that's maintaining a cryptocurrency or something is that there are fungible tokens. There are tokens which say this token stands for some amount of cryptocurrency, and just like money, you can kind of exchange it for, you can exchange pieces of it. There's nothing specific about this dollar bill. It is just a thing that represents that amount of value, and it is a fungible store of value, so to speak. It's something where you can exchange it for other dollar bills, and it still maintains that same notion of value. There's sort of a theoretical question in economics, which, again, I'm not going to get into, which is kind of understanding what really is this thing that is kind of the maintenance of this sort of abstract notion of value in economics. I think that can be rather informed, actually, by some of the thinking that comes out of kind of physics meets blockchain kinds of ideas. In any case, so that's kind of the fungible token notion of something like a cryptocurrency. The idea of a non-fungible token is to have something which is unique. It's a different object. It's a piece of art. It's a unique certificate of something, which is kind of like your own private piece of currency, your own private currency that will exist as a permanent sort of token that you can exchange with people. Different people can own it and so on, but the actual token goes on and exists as a thing on its own that is not something that is just fungible into other tokens and so on. And the thing that's very interesting about NFTs and blockchain and so on is that, unlike kind of a physical object in the world, where you might say, well, there's just this one thing, this one electron, this one piece of metal, whatever else it is, or this one piece of art or something that is kind of unique and indivisible. It is something where you can make a computational contract that makes all kinds of complicated things happen with that NFT. It can have multiple owners. It can have things automatically happen at a certain time. It can have features about when it's transferred, this or that thing should happen, all those kinds of things. And so it's a kind of a more complicated, more virtualized version of ownership, more virtualized version of identity than we've been used to before. And it's something where you can imagine that there's a thing and it can split at some time, or it can maintain some number of copies of itself, all those kinds of things. And these are all definable by some kind of computational contract. And I should say that the part of the reason that I've been interested in computational contracts is computational contracts I view as being sort of a generalization of the idea of smart contracts. The reason I've been interested in them is that I'm sort of interested in how do you represent sort of everything in the world computationally, and I've been spent the last 40 years basically building what's now Wolfram language, our language for representing things in the world computationally. And those things in the world can be sort of abstract kinds of things that live on blockchains. They can be real things like cities and places and pieces of food or whatever else that are represented in some canonical way in our language, and about which we can compute things, and about which we already know lots of kind of computational knowledge about how to compute with those things. Why is that relevant? Well, for example, if you're trying to write contracts about what should happen in the world, what we typically do today is we write those contracts in English or legalese or whatever, but the concept of a computational contract is that that's something that can now be written in computational language. It can be now written in something where there's a computational language that can refer to real things in the world, can refer to whether it was raining tomorrow, can refer to whether this machine learning classifier thinks this is a good piece of fruit or not, can refer to all these actual things in the world, things about IoT devices and so on. All these things are things that we've tried to make be a sort of standard part of the computational language that we've been building for the last, 40 years basically now. So that's why I've kind of been interested in this notion of computational contracts. It's something where, in addition to the things that happen purely sort of at the level of smart contracts, things that are on a blockchain that refer only to sort of the things that can be known to the blockchain, a computational contract is something that can know about knowledge about the world, can know things about what's happening off-chain in the real world, so to speak, and can mix all those things together and be represented in a standard way that can be, for example, stored and executed on a blockchain. So, in any case, the thing that we would want to do with any when we think about the sort of the point of blockchain is, okay, things that are on the blockchain are publicly findable to anybody. So let's just go and start doing things here. So this is, I'm just going to start up this is just a standard Wolfram language notebook, and so I can say something like blockchain block data, for example. Let's just say let's look at the most recent block that was mined on, I don't know, let's say Ethereum. So this is now, within our language, this is now looking at that most recent block mined on Ethereum, and we can do all kinds of computations with the things we find here. So we could, so for example, we could say, let's look now, let's talk about NFTs on Ethereum. The most common way to make an NFT is with an ERC 721 smart contract. And so we could, for example, pick up, let me see if I have a nice way to do this. We could, for example, let's go ahead and just try and do this here. Let's say we ask to pick up all ERC 7, well, let's do ERC 721 here. Let's look at, well, actually, let's just look at, okay, let's look at ERC 721. Okay, so this is now looking up the name and the count of the number of transfers of all ERC 721 tokens on the Ethereum blockchain. So let's go ahead and just make a word cloud to just give us a sense of what's there here and find out what the most commonly transferred okay. There we have the all-time winning CryptoKitties as the most commonly transferred NFT on on the Ethereum blockchain. I don't know. I wonder if we look by number of holders. I wonder what the whether we get the same result here. So this is just using Wolfram language. That one of the things it knows about the world is it knows about blockchain. And for example, here it knows about the Ethereum blockchain. Okay, what is this? Is that strange Austrian post office thing? I don't know. I don't know what these are. But anyway, so this tells us on the publicly visible Ethereum blockchain, this is the NFTs. This is information about the NFTs that are stored there. Okay, so the thing to understand about NFTs is, well, we could look at the actual form of an NFT. Let's take an example of, okay, let's take an example here of, let's see, what is this? Let's see if I can get this here. This should be a cyberpunk NFT. Let's see, this shows us the transaction data associated with one of those NFTs, and we might be able to see, so we'll see here information about, I wonder what the input data is there. What is that? Is that something interesting, or is that something completely boring? Well, we can always find out. Let's say here, just get the input data. I wonder what that is. Hard to know. Well, there it is as bytes. I wonder whether those bytes look like anything interesting. Let's see, we could always say partition that. This could be dangerous in I don't know, let's say size 64, make a guess. And let's make a picture here. Oh, that was completely boring. In any case, the so I'm not sure what that, whether that will actually store anything interesting, but that's an example of an NFT that is attached to a piece of art and this, I guess, is the list of events that happened for that particular transaction. And we can go and extract, oh, I think what we can do here, this extracts the kind of the cyberpunk ID number that is associated with that particular NFT. There it is. I think there are some other NFTs that have a little bit more actual information here. Let's see, I think this is an autoglyph where we can actually find on the blockchain itself. I wonder what this looks like if I just look at this. Actually, I'm just curious. Okay, let's look at that. Okay, it doesn't look like much. That's the data associated with that particular transaction. But if we process the data in the right way, we see, well, something that might be a picture. It's like one of those things that we've sent to supposedly to the extraterrestrials and see whether they can decode it. It's kind of an interesting question. We looked at one point at all the graffiti on, for example, the Bitcoin blockchain, and the question is there actually intelligent life on the Bitcoin blockchain, and can you tell by looking at the graffiti on the blockchain? It mostly says mined by and so on. Okay, let's see, maybe one more example of an NFT collection. Let's look, instead of Ethereum, let's look on Tezos. Let's look at the Tezos blockchain. This is a preliminary version of our hookup to Tezos, but let's see, we can maybe maybe look at this, and oh gosh, what are those? Are those some kind of those must be some kind of emoticon, emoji. Okay, so anyway, there are some NFTs stored on the Tezos blockchain where at least their image is recorded by an emoji there. All right. Well, let's see. We can look at other examples of that, but let's not do that. Let's talk about what the significance of NFTs actually is as I see it. I mean, so one of the things that one can do with an NFT is say, here's this token, you can transfer it around, but some definite person owns it and it can be transferred to other people. And that can be associated with something, either a, yes, I own this piece of art, or yes, I have the rights to do this particular thing in the real world, or yes, I'm this particular person and somebody verified that in the real world, and so on. But I think that a very interesting kind of way to think about NFTs, and that's more related to the live minting kinds of things that we're doing here, is NFTs are kind of this way of storing information about something that happened in the world, or something that was one of the features of an NFT and a blockchain in general is not only does it record a thing, but it also records the creation of the thing. It records when the thing was created. It has a notion of the progression of time, and we get to insert this thing at a certain moment in the progression of time, as time is recorded both on the blockchain by timestamps and on the blockchain by virtue of the succession of blocks that exists on the chain. So NFTs are this sort of permanent record of something at the moment when they were minted. So the question then is, what do you want to record? And the thing that I think I realized is that there are lots of things you might want to record that are essentially a recording of history. They're sort of a computational legacy. They're kind of an NFT becomes kind of a beacon of computational legacy that you can put on the blockchain and expect to be maintained because of the desire to maintain the future integrity of the blockchain. So the question is, what kinds of things might you record? What kinds of things? They might be things you create. They might be achievements you have. They might be things that you can certify about yourself, those kinds of things. And in the end, you can expect that those are things that are associated with you. You own them. You have the private keys that go with those NFTs. You are the owner of those things. You can have a wallet that can display, that can arrange those NFTs for you, and potentially you can whip out your phone and show somebody, look at all these cool things I have that are mine as NFTs, and somebody can go verify that by checking that using your public key and so on, that yes, they really are your things. And then you can expect that these are things where the sort of the first use is they're things you did, you achieved, you created, whatever. You store them on the blockchain. And they will be stored forever there. And you can show them in your wallet, things like that. Now, maybe some of the things you create will be worth more to somebody else than they are to you, and you will want to sell them to somebody. And that's, of course, something that you can potentially do. It depends a little bit on the computational contract of the NFT. If the NFT that you got is a certification that you're a certified something or other, then that isn't something where you can expect to sell the certification to somebody else. It's like you might have a passport, and when the passport is used, it gets canceled, and the canceled passport might be something that's an interesting artifact to sell to somebody, but the active passport is a different thing, and that's the kind of thing you can expect to encode in the computational contract. But the notion is that then what you're doing is to create something which is primarily for yourself, but it potentially has a secondary market that might be for the future, where yes, this thing that I made is something that is something that's going to be valuable to somebody else, and you can then sell it on the secondary market, and potentially have some sort of rights that get taken along as it gets sold. Maybe you get a cut of successive sales of the thing. Maybe you get certain rights to affect how it can be used, and so on. And by the way, as one starts thinking about how to do this, and one starts thinking about these kind of time capsules that you're dropping onto the blockchain of things that you create now as NFTs, these kind of beacons of computational legacy that you can expect to have something happen with in the future. You can do all kinds of things with computational contracts. You can have the thing be encrypted. You can say, I'm going to put my memoirs out here, but they're going to be encrypted until such and such a time in the future, or until this set of addresses agrees that this thing should be revealed. Or you might have something that involves multiple people where some aspect of their involvement is not visible until they confirm it by making a transaction on the blockchain and so on. So there's a whole lot of things that can be done in this kind of in the meeting of computational contracts, and which relate both to, you have to have this kind of computational language to express these kinds of things that happen in the world and things that happen on chain and so on. And but you can expect to build quite elaborate ways of maintaining your kind of computational legacy and controlling your computational legacy as you choose, so to speak. I think that this question of sort of what it is you're really doing with this kind of computational legacy, in some sense, there's kind of the merit badges for life type concept of different things that you can get for different achievements you make. But there's sort of a whole thing you can do. And the other thing is that once you have a computational language to express things, not only can you express what can be done with that asset in a computational language, you can also represent what that asset is in a computational language. So you can expect to kind of weave this complicated kind of computational web of different kinds of pieces of computational legacy created at different times in different NFTs and so on. You can expect to kind of you can expect to kind of weave those things together in a way that depends on the fact that you have kind of a computational representation, not only of the sort of meta activities to be done with a token, an NFT, whatever, but also with what's actually in that token. So, okay, another thing to mention is as one starts imagining creating NFTs that represent all sorts of different things, there's this kind of interesting kind of chain of trust. I mean, in the case of sort of the something which is sort of the pure cryptocurrency of a blockchain, it's kind of the whole blockchain is responsible for kind of the maintenance trust of that. But in the case of an NFT, which is supposed to represent something in the real world, we have this this question of so really, did you actually get that certification? Did you actually do that thing? It's sort of interesting because we've thought about that because we maintain kind of the largest computational knowledge base in the world in Wolfram Alpha that supplies Siri and Alexa and now Excel and all kinds of other things with computational knowledge. And we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is how to make sure things are correct. And so that's something that as one starts imagining things being sort of added in NFTs, there's a question of how do you validate that this thing that you say happened actually happened? It's actually a more difficult problem than most of what we have to deal with these days in Wolfram Alpha, but it's kind of a story of kind of validating IoT data with models and machine learning and anomaly detection and so on. It's also a story of maintaining kind of chains of trust to organizations that you as the kind of receiver of these things choose to trust. Well, okay, so let's see. So let's get to some live minting and so on. So what we've been kind of doing a few experiments on this, and we did as part of so we just did another very different activity of mine. We run every year a summer school for all kinds of people doing science and technology, as well as a summer camp for high school students. And as part of that, I was doing some interviews with interesting folk that I know. And one of those interviews happened to be with Nassim Taleb, who's a bit of an avowed non-believer in the long-term value of cryptocurrency. But just for fun, we did as a first test of live minting an NFT, we kind of live minted an NFT associated with the conversation that I did with him. That was just done on the Cardano testnet. And let me just show you that if I can. This should be the transaction that minted. That's not very clear what's going on here, but maybe someplace here it actually has some words here. Oh, look at that. Stephen and Nassim V0.1. Okay. And it references So this is actual data that's on the blockchain here. This is just pulled from that particular transaction on the Cardano testnet, now here there's an image. That image, that's the content hash of the image for IPFS, and presumably it's still current in IPFS. That particular particular thing is still findable. Right now, I'm not. Computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir and Alex Allen, all kinds of other things with computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir and Alex Allen, all kinds of other things with computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir and Alex Allen, all kinds of other things with computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir and Alex Allen, all kinds of other things with computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir and Alex Allen, all kinds of other things with computational knowledge, and we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is, Serene Elixir. Thing that is. Oh yeah, there we go. Very nice. So I just imported that from this, downloaded from IPFS, the content hash from the NFT that we minted, put on the Cardano blockchain, the content hash of its image here, which was specified by IPFS, found somewhere out there, and now imported into Wolfram language and displayed there. And this is one of our sort of graduation tokens, so to speak. So that's an example of how that works. I think we also have when you I think this is something which if you had a wallet that would have Cardano NFTs in it. That's not something that's quite ready yet, but I think those are coming. Then you can expect to have little thumbnails that are pulled out from these kind of standard fields in the NFT to show you what it is that you have in your wallet. Okay, so that's a little bit of the story. And by the way, it's kind of fun to realize that a little bit of the kind of computational legacy of our experiments with NFTs is already written onto the blockchain, and in this case on the Cardano blockchain. There's also some on the ARC testnet, as well as the Cardano testnet, and some other things. Okay, but let's get to today's live minting. So I wanted to pick something that was an interesting kind of thing to live mint, that is sort of a mixture of art and event and discovery, and it's something very much a favorite of mine, something from the computational universe. It's something where when we think about sort of things in the world, we might think about I don't know, a chemical element like gold, and there we have the chemical element gold, and we could say, what's the density of gold or something like that. That's an entity that exists out there in the real world, so to speak. We can also think about things which are just sort of abstract entities which exist in the computational universe. Now, of course, it's sort of a confusing thing for somebody like me who's tried to figure out how the actual universe works, to realize that the actual universe is in some sense just a computational thing all the way down. we now have a pretty good understanding of what kind of the structure of the machine code for our universe is, and it's in a sense just computational, so to speak. And but here we can say, let's look at the sort of computational universe of all possible computations. That computational universe of all possible computations is very big. It includes, for example, our physical universe as a part. But this sort of computational universe of all possible universes, we can say what's out there in that computational universe of all possible universes. What kinds of things, when we write programs, usually we're used to writing some very complicated program for some particular known purpose. We can just say, just go out there into this computational universe of all possible programs and let's see what's out there. Well, a long time ago, I got very interested in doing that as a way to kind of understand how the natural world works. It was in the beginning of the 1980s. And I sort of got interested in what were the simplest programs that we might study as examples of kind of things that are programs that exist in this computational universe of possible programs. And so I particularly started studying these things called cellular automata, and the version of them that I looked at just have a line of cells, say each either black or white, and at each step, then the color of the cell of each cell is updated according to a rule that depends on the neighbors of that cell. So here's a particular rule. Let me show you. We can do something where we say, well, back in the day, this was what I generated as kind of the what do cellular automata do. But fortunately, it doesn't really matter whether you're doing ASCII art or whether you're doing something else. We can now say, okay, what do all these cellular automata do? And we could say, let's just compute for a bunch of cellular automata. Let's just compute what they do by just running them all here. Let's say we run the first 64 of these things. Oops, what did I just do there? I did the wrong thing. Let's say, actually make a picture of each one. So here are the first 64 kind of possible programs of these cellular automaton programs kind of plucked from the computational universe. We're kind of looking through a telescope at the computational universe and asking what's out there. And yes, we get these nice nested fractal patterns. And then we get kind of my all-time favorite science discovery. This is Rule 30, where you just started off from that very simple initial condition, and you run a very simple rule. We can see what that rule is. Here's the Rule 30 rule. And if you keep running it for a while, you get a pattern that has lots of complexity. And this is a very fundamental thing that I've sort of built this whole new kind of science from studying. What am I doing here? Oh, I need a 30 there. So this is kind of the what Rule 30 does, starting from just a single black cell here. There's a certain amount of regularity, but many aspects of this pattern are completely random. And the fact that there is so much complexity that can be generated from such simple rules, I think that's kind of the secret that nature uses to make the complexity that it tends to make. And there are many, many consequences to this phenomenon of being able to start with such a simple rule and seeing such complex behavior. One of those consequences is a phenomenon I call computational irreducibility. Even if you have a very simple rule to start with, knowing what consequences that rule will have is sort of irreducibly complex. To know what will happen kind of a billion steps in the future here, there's sort of no choice but just to follow a billion steps of evolution and see what happens. There's no way to kind of predict and be smarter and jump forward, so to speak. And that phenomenon of computational irreducibility that I first started talking about in the early 1980s, it's one of those things where if you're a scientist, you never know where your science is going to end up. I think that's the sort of ended up being the conceptual foundation for what became things like proof of work in blockchain, which is a very bizarre outcome from something which was a piece of basic science about sort of the predictability of systems that pretty soon you're guzzling huge amounts of electricity to do the thing that corresponds to that irreducible computation. But in any case, so one of the things that is nice about these cellular automata plucked from the computational universe is they make patterns that we find interesting. This is from like 1984. I turned.
Serena lecture, and now explore and all kinds of other things with computational knowledge. And we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is Serena lecture, and now explore and all kinds of other things with computational knowledge. And we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is Serena lecture. Serena lecture, and now explore and all kinds of other things with computational knowledge. And we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is Serena lecture, and now explore and all kinds of other things with computational knowledge. And we try to maintain this kind of Serena lecture, and now explore and all kinds of other things with computational knowledge. And Serena lecture, and now explore and all kinds of other things with computational knowledge. And we try to maintain this kind of integrated computational knowledge base. And one of the things that's of great interest to us is Serena lecture. Serena lecture, and now
So we'll have about 1.2 billion possible rules of this type. Each one of those is kind of a potential source of aesthetic content. It's kind of like we could take a photograph anywhere in a billion places, and let's pick which photograph we take. Okay, so we've got these billion possible rules, and we're going to pick some of those billion possible rules. Okay, and let's make it a little bit prettier than just gray and white. Let's just put in some colors here, and let's go ahead and just generate. Let's generate 9 of those. Okay, so this is now. So we now just generated 9 kind of randomly generated objects from the computational universe, and what we're going to do here is we're going to be picking the ones that we think are aesthetically interesting, and that's something that's really a matter for us humans. What's out there in the computational universe is just something very abstract. It is what it is. It exists. It inevitably exists, necessarily exists, so to speak. But the ones that we decide are interesting, that is a human choice. Actually, what we now understand about the universe is that the sort of choice of how we parse the universe is something very specific to us. That's kind of what happens in the universe, and kind of the ultimate events that happen in space-time and so on are things that there are many more of those than the ones that we choose to pick up by our sort of sensory apparatus. And this is a very miniature version of the same issue of which pictures here do we think seem interesting. Okay, so I'm going to guess that one is going to be kind of interesting. And one of the things to realize is that these pictures, as we run longer, let's take that one. As I mentioned with Rule 30, there's this phenomenon of computational irreducibility, and that phenomenon has the consequence that it means we don't know what's going to happen, so to speak. We can't know what the ultimate behavior is going to be. And here, if we run, well, let's see. If we take this particular rule, and we might run that rule. Let's pick this. Yeah, let's see how to do this. Let's do this. Let's pick this particular thing, and let's run this. And there we go. And let's run this longer, and we can kind of get a sense. So 450 steps, let's run at 1,000 steps. And, oh, wait a minute, what happens here? That was, is that the same rule? Oh, maybe it is. You see, that's what happens. See, if I run that for 300 steps, for example, looks pretty interesting up there. Well, actually, this was many fewer steps. This was only 80 steps. And so running it for 80 steps, it's looking like this one's a winner. But what we're going to do, and what we're going to use as our sort of standard number of steps for our NFT is 450. And at 450 steps, that one looks like a loser. So we can try, let's try, let's just to show how this works. That one is a possibly interesting one. Let me see about that one there. And I can show you what some of these others do. Let's go ahead and pick these 2 here. And let's go ahead and use those. I think I need to write my code slightly differently so that it works more easily here. Let us go ahead and do this. Yeah, let's do this. And let's go ahead and map that over these. Oh, there were 3 of them there. Okay, so these were the 3 that I picked running for 450 steps. So that one is kind of amusing, but it's kind of a mess there. This one here is lovely, but I recognize that is the Rule 150 additive cellular automaton pattern. It's a nested pattern. If you go look at this pattern in more detail, you'll discover it has a fractal dimension that's determined by the golden ratio and log of the golden ratio and so on. And it's kind of fun, but I consider it to be a same old kind of pattern. Okay, so I think none of those were really huge winners. This particular one here. I kind of recognize these. I've been a hunter of cellular automata for a very long time, so I tend to recognize these things. All right, let's go look at a few more here. Let's go look, instead of at 9, let's go look at 50 of these things, and let me make them a little bit smaller so we can get a little bit more on the page. And as kind of a seasoned hunter of these things, I at least claim I have a decent chance of being able to pick out ones that I think will be interesting. Okay, so I think that one might be interesting. I think that one has some promise. I think this guy here is promising. That one is a maybe. And yes, we've had all kinds of machine learning systems to try and solve this problem of figuring out which ones are going to be interesting. And the problem is, if you have one definition of interestingness, then your machine learning system can pick it up. But the surprise, it's hard to pick up a surprise, so to speak. All right, let's go use this here for a second, and let's no, not that one. Let's go use this one I had here. And let's go look at those rules that I had, and let's see whether we can find one that we like. Go. Okay. See, I told you that one would be kind of interesting. All right. That one turns out to be kind of dull. This one here, that one's kind of fun. It's a little bit, I suspect that one will go on being interesting, although if we're only doing it for 450 steps, that's kind of all we have. That's kind of the down arrow. I think that's kind of fun. And this one here is, yeah, I've seen a lot like that. I'm afraid it's made by its yellow more than anything else, which kind of is a bit of a cheat. But I reckon that this one here, again, if I ran that third one there for longer, I suspect it will do something even more exotic and interesting. Let's pick it there just for fun, and let's try running it, not 450 steps, but let's say try running it for, let's just say 1,000 steps. And I should write a little function that does this here. Let me just do that. Let's say, let's just write something called, let's be very boring and let's just call it CA pix. Is this? And let's say, this thing here. Okay, so that is making, there we go. So it's kind of like, it's like a bunch of waves that are crashing together and making a more and more complicated wave pattern. All right, well, I think it's time to actually mint some NFTs here. So I kind of like this one, and I kind of like, I do like this one. And I think this down arrow one is interesting just because it has down arrows in it, and we can kind of recognize, we can say something sort of at a human level about what it is.
It also looks like a person. Sorry. You know what I mean? Like a face. With a goatee.
They always look like faces. Oh, this one here. Oh, yes, right. Yeah, you can always, so you know, one thing we can do with one of these is we could always say, if we really want to, let's go machine learning on this. Let's say, let's use image identify, and let's say, image identifier that's been trained on lots of real world images. I think it's art. I'm now super curious, actually. If I just run it across some, let's see, line 35, if I just run image identify across all the things on line 35, just what will they, let's just do 5 of them here. Let me just go ahead and say labeled so we know which is which. Let's go see just how weird the names it comes up with. Those were very high resolution pictures, so it might take a little while for the neural net to grind through them and try and analyze them. Okay, there's a lot of pyramids here, as well as Washington monuments. Okay, so it's pretty certain that's the Great Pyramid. Well, maybe it's the yellow. A jigsaw puzzle, a game, an apron, an art, a piece of cloth. Okay, so both of these managed to make it as art in top choice. A lancet window. What is a lancet window? A stained glass window. Okay, that's the sort of verticalism of the whole thing. So, okay, all right. Well, let's go ahead and now that we picked some, we think, as a matter of fact, it's kind of interesting, isn't it, that the 2 I was going to mint are the 2 that the image identifier said were art. Fancy that? Quite a surprise. All right, let's go ahead and pick up those particular ones. Let's see, it was very low tech. They were numbers 3 and 4 there. So let's go ahead and pick out numbers 3 and 4 here. And this is kind of our, the very beginning of all these things. It's always hand done. There's numbers 3 and 4. Now let's go and we've got a nice function that previews these NFTs. So let's go ahead and make a preview of that first. Well, let's go ahead and preview we can go ahead and preview both of these. Actually, no, let me just preview the first one. So here we go. So let's see what we're going to make here as our actual piece of NFT art. Okay, there we go. So this is now, I'll make it a bit smaller so we can actually see it. This is, I wrote this out earlier today, and this is just image composited onto the onto this image, and there's the actual code, the actual description, the actual computational description of what this is that we can permanently store on the blockchain is right down underneath there. But this is the visual asset that is going to be stored through IPFS that will correspond to this NFT. Okay, well, so with that in mind, let's go ahead and see whether we can actually mint an NFT here. So what we need to do is, let me see here. This is the moment when everything breaks. Let us go ahead and say, I'm going to do this first of all as a test. I'm going to say Cellular Automata mint NFT. That's a function we wrote earlier. I'm not going to actually put this out on the blockchain. I'm just going to do a test here. Let's take this, which is our specification, and let's call this, I think we should call this crashing waves, because that's what it kind of reminds me of. But we're going to ask our panel here, but this is just a test, so I'm just going to see what it does as a test. So this is now going to show us what the transaction that it would be pushing out there to actually mint this as an NFT on the Cardano mainnet blockchain. Okay, so here it is, and this is now saying it's going to cost us this amount. I'm embarrassed to say I don't know what the subunits of ADAs are, but hopefully that's in the subunit.
Lovelace.
Lovelaces, okay. The let's see. The we can probably wonder whether we know this.
We haven't pushed that yet to production. Oh, we have. Try it.
Let's see whether we can say currency convert that to USD. Didn't know it yet. Oh well, coming soon. Okay. All right. So okay. So this is now the transaction that will be used to mint this NFT on the blockchain. And I have to say, you just heard from Christian there, who is our ultimate minter. And when we were doing this as a test for our summer school, the result of Christian probably did the very first time anybody has tied to live mint a whole block of NFTs on the Cardano blockchain at a time, and needless to say, Christian broke the blockchain, and we made a little commemorative T-shirt. Here, I'll show you the Christian's commemorative T-shirt, for which was Christian, I think, is styling the folks who minted coins back from the Middle Ages to today, but with the quote, "Everything was working before it broke." So let's see what happens for us here today. I should show actually the what we minted. That this is the images of those were the NFTs that we minted as part of our summer school. These were just presentations people did at our summer school about lots of different topics, about physics and all kinds of other things, even a few about blockchain. But those were the things that were put as sort of the certificates on blockchain. Okay, I see there are all kinds of questions, and we will have a chance for lots of Q&A in a little bit here, but let me see if I can actually do our actual live minting. So what's going to happen here is we've funded this live minting by putting cryptocurrency on the Cardano blockchain. That's what's going to be used here to pay for this live minting, because in a sense what's happening is we're in a sense paying into this system which is going to preserve this information sort of forever, so to speak. So let's see. So we are going to use, so here, let us go ahead and let me explain also what's going to happen here. We have 20 NFTs that we're going to create in this session, and each one of those has 20 copies, and we will be making all of them available eventually as NFTs that you too can own. The process for doing that is still a little bit manual, so it's going to take a little while to progressively make those available.
I think they're going to be available. That auction is going to be available actually on Monday, next Monday now. So.
Okay. Well, it's a by hand process, so 6 days. Some of this stuff happens instantaneously. Some of it's probably about the same time that it would have taken in the Middle Ages if you'd been minting coins and having them delivered by, donkey cart or something to somewhere else. But okay,
we should buy an old coin mint. Like, I wonder, did they do that by hand, like with a clink or something?
Yes,
like some sort of leverage.
Yes, before they had steam, it's some. In the words of Ada Lovelace's friend Charles Babbage, when he was first interested in the problem of computing, which he got interested in because at the time it was the 1820s or so, he was he'd realized that no, it must have been a little earlier than that. He'd realized that Napoleon was off having all kinds of mathematical tables computed in France by lots of people, and he realized if the British were going to stand a chance, they better have mathematical tables too. But it was a very tedious process to compute all these mathematical tables. And famously, Babbage said, I wish to God this could be done by steam, which was in those days a kind of automation. And then he spent many years trying to develop this idea of automation, which the aforementioned Ada Lovelace was really the one who realized that it wasn't just an engineering problem, it was actually a very important conceptual idea, this idea of computation. And that's what she wrote about in 1835 or so, about the analytical engine. All right, that was an irrelevant piece of history, but perhaps of interest. You know, they talking of things happening quickly, those two used to exchange, well, I was going to say mail messages. In those days, they lived a mile and a half apart or something in London, and there were, I think, 14 mail deliveries per day at that time. So it's not much different from our email rates today. All right, so, okay, let's go ahead and actually mint something here. So we are going to take, so this is, what do people think about this name, crashing waves? Can we do better? Any suggestions from our small panel here?
Let's go with that one for the first test.
Yeah.
Okay, all right. Crashing waves might be, now the real point about the term crashing waves is we're looking for it not to be kind of a pun word, because we're looking for this not to crash. Okay, so this is going to be, we've set it up so that number one is the first funded NFT here. So let us go ahead and let's clear our screen and the first live minting, and we got to get that ready to go. Okay, drum roll here. You know, we really need to compose this. We should be able to get from the computational universe, from Wolfram tones or elsewhere, the great sound to make, perhaps even to go with the names that we're putting here. All right, no, without further ado, let's run this. Come on now. What is this doing? What on earth is this doing? Why is this loading in something about systems engineering? That is a very bizarre thing and definitely not looking like it is a correct thing. Why would it be doing that? Well, okay, something seemed to work here. All right, so what did this just do? So this claims that it minted something on, so let's take a look at what source says here. Let's take that IPFS URL and let's say, let's go ahead and say, okay, there's the description, there's the string, which has the Cellular Automaton code in it. There's the NFT ID, which is something, okay, so let's go ahead and take that and let's see whether we say external storage get, is that what we want, or download? External, let's do external storage get, that should work.
No, you want download.
Okay.
Get is for expressions.
Ah, yes, this is, okay. So I'm going to say download, and then I'm going to say import that, and let's see whether this will actually, so this is now just something out there in IPFS. Ooh, bad. Oh, maybe I have to tell it. Why would it not know from the URI that it's an IPFS?
Oh, you just need the content ID, so remove that protocol. But we should support that, yes.
Ta-da! Okay. All right, so that's out there in IPFS right now. And now let's go look at the transaction ID. Here's the transaction ID. This should be the transaction ID from the Cardano blockchain. So if I say blockchain transaction data of this, and then I say, and this I think is only available. Is this is available to people, right? This
yeah.
Why isn't it in the
be able to run this?
Didn't quite make it into the autocomplete, but hopefully, so I can just say that. What's that?
This is a pre-release version, the one you are using.
Ah, okay. So there we go. So there it is on the Cardano blockchain. Let's see, when was this put on there? So let's see, the timestamp there is this, and let's say now minus that, and that was 2.2 minutes ago. Sounds about right. So we can see there, this is in block number 6 million and this block on the Cardano blockchain. So let's go ahead and just for fun, let's go see what else got put on the Cardano blockchain along with us in that block of the blockchain. Let's see. Okay, so let's look at that blockchain base.
You should be on Cardano already with as your default blockchain, so you don't need to use the blockchain base.
All right, so this is now, so this is that block, total transactions 4. This is the list of transactions. So we were one of those transactions. And I don't know what this is. I don't know the Cardano blockchain well enough to know what that is. What is that? I'm very curious what that is. I'm going to pull that in just for fun. Let's see, URL, and find out, whoops. Oh, is that?
Oh, it's inside the slot leader.
Leader.
Yeah, so it's information about the leader.
Okay, so let's say slot leader. Okay, and then let's say import that.
So there should be the pool that added the block.
This is explaining that what this is. This is some kind of graffiti on the blockchain, so to speak.
Yeah.
Well, except it isn't. It's just pointing to a URL here and explaining something about what's on the blockchain there.
It's a stake pool.
I see. It's some proof of stake mechanism. Cool. All right. Well, anyway, so there we have it. Our NFT is now on the Cardano blockchain. We can find it. Can we? But from its transaction ID, we can go back, find the transaction it was in. Within that transaction, here is here's the information, and there's that. This here is the actual data, crashing waves, and the description that we put onto the blockchain here. And to store this content, we have to go to some kind of Filecoin-like back end, so to speak, and expect to kind of fund the permanent storage of this big object. Now, of course, we don't really need the big object in this particular case because we have a very succinct computational description of sort of everything about this that's sort of interesting in some sense is contained in that little piece of computational language.
I think that's really cool. Like Christian and I have like spent all this time like working through other blockchains and other stuff, and it's like we have this succinct language where we can do that. You know, I mean, of course, you know.
I've only been working on it for 40 years, so yes,
right.
I figured that out by now. If I hadn't, I would be. But yes, this is okay. Well, let's go back. Okay, so we did our first live minting. Let's go ahead and do a second one for this. Let's put that on. So we'll go ahead. That one was, this is so low tech here, but you see, this is what happens. Always at the leading edge, there's something extremely low tech. And in this particular case, I didn't make this an auto selection thing. I'm just counting from the end to that particular description there. Okay, so now we have to decide for this, what are we calling this? I like the down arrow. But that's what I see as a down arrow. Now, I'm not very big on seeing. I mean, if we did this here and we say, see, I reckon if we were to say, the test of whether it's a face, right, is to say, if I just take, if I go ahead and capture something here and say, there we go, and I say, facial features of this, it'll tell me it's a face. Now, the question is, if I take this picture here let's take that picture.
Can you cut out the rest of the? I mean, it's kind of not fair because it's like it's the pyramid part is going to throw it off. Can we cut out?
It found my face in this big thing with a bunch of weird background in it. So that's.
Why does it say you're sad?
So what's that again? Say it again. Oh, it says I'm sad. That's really bad. It's really outrageous how accurately it seems to get ages. Although I have this terrible feeling that I might be in the training set. So it's but let's take this and let's try running facial features on this. I think it's going to just be a total fail. Oh, actually, you know what I need to do here? Let's actually take this. I'm going to make this into an image because I'm not sure what it's going to do. It isn't an actual image. There's no face there, it says. You know, it's kind of like that. I'm not going to go after the, you know, maybe if we make it, okay, let's see whether it somehow thinks. There's no way it's going to think there's a face there, but I think it's even more hopeless.
Yeah. I can totally see an owl there.
A which?
More like an owl face than a human face.
Well, let's see what it thinks it is. That's see, this is a very strange process because we're all, you know, our image identifier has seen 30 million images. That's what it's actually a little bit more, 50 million images now that it's been trained on. We humans see in the first few years of life, see maybe a few tens of millions of distinct images of objects. And so we are, let's just ask it probabilities here. The question is for each of us, we've seen, okay, stained glass window. Yeah, well, there's a lot of color stuff there. A protractor. What is a lancet window anyway? Let's, what is that? Let's hope we actually have that information. A narrow window having a lancet arch and without tracery. Okay. Also could be a kazoo, according to this. Okay. So, well, what do you think? Down arrow?
Yeah, it's close. Let's just do it down arrow.
All right, so we're going to call it down arrows. And we're going to say here, I'm going to take my my minting machinery, and I'm going to say here, well, let's just take this. Let's preview it, just see what it will look like. Just check nothing too bad happens here. Where is it? It's there. Okay, so this is you know, in the 1.2 billion possible photographs, so to speak, in this part of the computational universe, this is sort of photograph number 233 million, etc. Actually, just to say what it is, right? We can, you know, I'm just doing computation games here, but you know, if we really want to say, we can say it is. What is it doing? Oh my gosh, what is it doing? Help! What's happening? Oh, there we go. 233,552,410. Okay, so let's preview this. Okay. Yeah, that has quite a rich texture, doesn't it? Really, yeah. Quite rich texture. It's really pretty nice. And you can kind of see it's almost, it's kind of almost reminds me of some kind of, you know, lake with a whole, you know, a dam and a lake or a river.
It looks like it's melting.
Well, yes, the whole thing, right? But turn it on its side. What's it going to do if we turn it on its side? I'm not getting that. Let me see what happens if we turn this one on its side.
Is that something significant? I don't know. Let's see if I go 270 degrees. I don't know. Somehow it reads very differently to us humans.
It looks more like a plane that you can eat inside, like a rocket or something.
But I think we're going to go with the verticalized, so to speak, version here, and let us go ahead and mint this guy. Okay, let us see here. We want to mint this, and what we would do.
Remember to change the key.
I will change the 1 to a 2. This is now our second in our series, and I got to change the code for it, otherwise we'll be minting the same thing, which will be no fun. And I've also got to change the name to downloads. Okay, we're good to go. All right, let us mint. Now I'm very curious if do we have word translation? I'm just wondering, as this mints, do we have? I wonder the word mint. Okay, there it is. It's up and running. Okay, I'm just a little bit curious. What languages we have? Not very many languages do we have a translation for the word mint. I'm just kind of wondering whether there's a let us mint, whether there's a nice Latin phrase that might have been used for the last few thousand years for that when people minted coins of various kinds. Okay. And who knows whether some of these might be, I think bonbon à la menthe is probably not mint in the sense that we are thinking of mint. I rather think that it's
it doesn't mean candy.
In fact, look at these. These are probably every single one of these is mint in the sense that I wonder whether how many languages.
German too. Yeah.
Maybe for coin we have. Oh, there we go. That's a much more. So many more languages kind of know about coin. You know when you have names of plants and so on, languages tend to be very different about those. Even within a country, even within a language, within a country, there can be completely different names in different parts. And of course, some plants grow in some places and don't grow in other places. But coins, well, I guess coins exist almost everywhere. Coins exist everywhere, at least for the time being. Okay, well, so we minted our second NFT here. So let's go ahead. We have, oh gosh, we have lots more to find. So let's pick up the pace here and go hunting. So let's get ready our hunting. I have to say, I have spent probably too much of my life doing these kinds of hunts. And I always say, if you have some theory about what these computational animals are going to do, one of the things that I've learned from years of hunting these things is the computational animals are always smarter than you are. So, anytime we think, oh, we'll never find one that does such and such a thing, just wait. So, okay, let's generate 200 of these guys. Come on, why is this taking so long? There we go. Okay, all right. I'm going to pick out some that I think are going to be interesting. That one is interesting. I like that.
They look like drops.
Yeah. Let me see what else is interesting here.
I love the red one on the blue.
Red on blue, that one there. I don't think that one's going to be that interesting. Its colors might be nice, but I think I'm a purist of what's actually going on in these things, and I think that they're, okay, I think that one has a chance of turning into something interesting, because remember, this is a low resolution, this is just a few steps, we're going to actually run it for more steps.
What about the column ones? What happens?
Well, they'll just be very vertical. I mean, we've got a square aspect ratio, and that one might conceivably be somewhat interesting. We'll check it out.
The purple and green one on the black background is pretty nice.
I think you're going for the color. You're not going.
Yes, but it is interesting. It kind of looks like a spider. It's second column. Second row, column all the way on the second to the bottom.
This one here.
Yeah.
Try it, but I don't think you'll like it in the end. Okay, let's see. This one might do something interesting. That one is somewhat promising. Oh, that one might be fun. That one has, you can see it's growing at different rates at the beginning there. Those can be interesting. That one might be interesting, or it might just become trivial. That one might be seriously interesting. Let's see. That one probably dies out, but it might do something really wild. See, this is undecidability in action, Gödel's theorem biting us. Of what's it going to do? We don't know. Just run it and find out. All right, let's try that one. Interesting, it might be. That one also has some potential, although I'm not super optimistic. Okay, that one probably is just going to have, this filling is going to be the same everywhere there. That might be interesting. Let's see. That one is promising. That one is fun, but it won't do anything more. It's done. It's just got these little things shooting out, and that's the end of it. All right, that's enough for these. Let's come up with those, and let's go ahead and take a look at the results here. Okay, what I'm going to do.
This is actually pretty fun. I wish I knew more.
Okay, so let's go ahead. That was my CA pix function, and let's go ahead and actually write the code to do this. And I wanted that interactive list selector, which is a little utility from our function repository, which I wrote because I got fed up with trying to do these kinds of hunts without it. And let's hope I got this right, and let's run it. Actually, I really wanted to do this a little bit faster. Let me go ahead and do this. I'm going to, just because we're going to be doing more of this, I'm going to go ahead and launch a few parallel machines. So hopefully, there we go. So it's just launching some parallel kernels to do the computations, so I don't have to run all the computations on the same core of my computer. So it'll just take a little while here. This is just my house, my little house collection of computers. I would say it's like house cats or something. It's house computers like house cats.
I'm not sure the cats in attendance will appreciate that.
Okay, all right. So we should get out these kernels here, and so now we probably want to. Okay, there are kernel symbolic kernel representations. So now, if I say this here, I can say parallel map of this, and this will now apply those things in parallel. Hopefully. Okay, so this is now going to just compute these results. Okay. Oh, I should. Yeah. All right. Well, let's take a look at these. All right. Well, that one turned boring. So much for that. See, it had promise.
Looks like a heart necklace.
Yes, it does. You don't get to see most of the necklace, and most of this one just looks like mush. See, this is. That one is just going to be a little bit in the center. Okay, so this is, these things have been a little bit, these things have turned much mushier than I expected them to. As I say, these computational animals, look at that. You see that one, I mean, it's just a lot of detail. You can imagine it. This is how, when you see fluid turbulence, you see water flowing rapidly. This is kind of the type of thing it's doing. It's making, in these kinds of ways, probably using rules very similar to these. It's just making, see, look at that one. That one looked interesting at the beginning, but boy, did it turn boring after a while. And this is, this phenomenon that things turn boring after a while. That's also the phenomenon of the second law of thermodynamics. It comes from the same place. It's the same thing. That these things, even though they're completely determined underneath, once you generate the results, they look, for many practical purposes, random. Okay, this one I claim is kind of fun. I think that one
looks like an alien.
Looks like what?
Like an alien. Or a bunch of praying mantises.
Yeah, you're right. It's got some eyes there. Aliens really need eyes. If aliens are going to experience space-time the same way as we do, they need eyes. That one, of course, just became periodic. Let's see. See, a lot of these, this resolution are just going to turn into mush. Okay, well, we've got one there that I think we want to use, and I'm wondering whether any of these others are going to make it. See, I think that this, am I doing this correctly? Is this 450, this is the, yes, this is the same as what we're using for the, for this, I believe. So let's just go ahead and do the one we liked at that resolution. So there, okay, there, just get that one, that, copy that, let's go ahead and paste that, let's say this. So I'm just checking that we actually are doing it. Yeah, there we go. So that resolution for this card here is, let's just check. That's right. Yeah, it's the same resolution as we had there. Oh, the difference is because it cut its wings off, so to speak, to make it a square card. Okay, I think that was rather nice. I like that one.
Yeah, I like that one.
I don't know what it is. Let's see. Should we ask the machine its opinion of what that is? Let's go ahead and ask the machine, just as a way to get a hint here. Let's just get its first guess about what that is.
It looks like a mountain.
Gateway arch. I'm not very convinced by that. Let's see. Let's see some other.
I think it looks like two praying mantises facing each other, which is dangerous.
Are they dangerous when they face each other?
Well, they end up killing each other, but yes. Well.
Okay, plot an optical device, laser, and Eiffel Tower. It's really big on this monuments thing. Okay, this only gets a 3% chance of art. That's because it's a new kind of art. It's just not art you've seen before. Sorry, machine. All right, let me see. What do we think this is? I'm not seeing praying mantises. Maybe I just haven't seen enough praying mantises in my life.
Lucky you.
I've seen alien invasion.
Alien invasion. Is that just because it's, or is that just because it's green?
It has eyes.
All aliens are green. In fact.
Oh, now I see the mantises. I see.
In fact, I think we could say that identically 0 aliens known today are green. Let's see. Somebody is suggesting I should be looking at this. The live stream comments here. Toxic ooze. I don't like that very much. I mean, this is kind of like hanging gardens, except the gardens are kind of inverted because the gardens are, the things are in blue and the background is in green. Fleet of spaceships. I'm not seeing that entirely. You see, in my world, this is a class 4 cellular automaton, but that's techno. That's in my strange world of technical things. You know what? Let's put this one on the side for a moment, and we're kind of going to come up with a name soon. Let's go look and see whether we can find some other interesting ones. A slice of aloe vera. That's interesting. See, one of the things to understand about these there's a reason why they look like natural forms, as I said before, because nature is using rules very much like these. So it is the case, while we get to scan over a huge number of possible forms of nature, there is going to be some sort of resonance with what you see in nature. But I want to look at, let's go just doing another exploration here, just see if we can get a few more things to look at. And I'm going to go ahead and do this again, and hope for, see, look at that. That one that looked so promising there turned out to be so boring when we actually ran it for longer, because it just, all those red, all that red trimming just was on the side. So, okay, let's see what we learn from this. Again, let's see if we can learn something here. All right, we're going to go ahead and let me just do this in parallel. It's always a complicated thing with parallelism. There's sort of a trade-off between what takes longer to transmit the data for versus what takes longer to compute. But let's go ahead and do this in parallel. Go. Yes. Okay, here goes. Now, if we really wanted to, okay. All right. Ooh. Okay, that's a fun one. Okay, I'm gonna use a little bit of. See, some of those. That one might be interesting. Some of these are just going to tell that one is going to be probably boring, but let's give it a chance. That one might be interesting.
How about like the bluish one with the sort of green
This one here?
Yes. Yeah.
It might be interesting. It has some, that one may be interesting, or it might just resolve into something trivial.
What about bottom right? Well, no, it's two rows from the bottom. Yeah.
Yes, it might be interesting. I agree. And somehow, yeah, I'm pretty sure I've seen ones like that before. That one might be interesting, probably not. That one might be interesting. See, what one I think, this is the problem, that what I'm looking for is something, is always, what we're looking for is something surprising. And unfortunately, it's very hard to classify surprising, so to speak. Why this is, okay, go, and let's take a look here. Probably not, but might be. Hard to know. Possibilities, I think. That one has possibilities, I believe, as well. Yeah, try that one, although I doubt it. All right, let's give this a try. Okay, so let's go look here. Let's do the same thing we did before of this. I could make this more streamlined, but see, this is the problem, that as soon as what you have to do is to anticipate the unexpected. And for that, if you make things too streamlined, there's a terrible habit of not picking up the really interesting stuff. All right, it's kind of interesting that we gave about the same number, we picked about the same number of ones to look at. Okay, here we go. Well, that's at least different. Okay, let's look at that guy. Doesn't really make it in those colors. And it doesn't really make it, it's again, a bit thermodynamic. That one I think is kind of interesting. I like that one. I like that one, and I like this one. I think this one is
Oh, that one I see. Yeah, that first one's a bit coarse, although its colors are kind of interesting. I don't know, I think it's kind of interesting.
It looks like a sweater and a tie.
It does have a certain tie, yes. Okay, so that one I agree is like the power tie. Organic power tie.
It also looks
Kinda
like a
looks-
volcanic eruption.
Yeah, or like I was gonna say the Empire State Building, like the power of,
I think I'm thinking that one is kind of an organic power tie. And the one on the right,
the train tracks
emerge.
That's a good title, actually. I like that. I think
Um,
that competes with crashing waves.
Right. Okay, so now we got this guy we got that previous guy to name. It's such a weird thing because it's like it looks very organic.
It looks like it's infecting something.
But that's again the
That's not a
color.
good thing in the pandemic,
I see the verticals. I see like acid rain. I like, or beam me up. Something that's these vertical lasers.
Oh, I see. You're noticing all the yellow
The
pieces.
lines, yeah, more than anything.
Well, I was gonna say like acid mantis. Which to me seems like
Why you
another
guys
nice
have
thing.
such negative
And now
comments?
see the starships from the comments. Like those blue things are the starships, and then the yellow lines are like the motors, like the gas they push out.
Now that I'm focusing on the lines,
They had a very if they've got their starships in a configuration like this, they're even doing much better than those guys who are trying to fly high altitude drones, which use their wingtip vortices to get a larger effective. This is a very complicated constellation. I mean, if you saw this, the first thing you think of, if you saw that in the sky, the first thing you'd think of is not that's a formation of things optimized for something or another. Okay, there's a
thinking about
here.
peace.
I agree. I am actually liking Avery's creeping vines because I do agree that there's a certain, there's some plant. There's a plant that I remember from long ago. Let's see whether I actually remember what it looks like. Wisteria. Right, is that the name of a plant? It is. Okay, let's see what it looks like. Oh, we don't have an image of it. Oh my gosh. Well, let's see whether if I do a web image search of that. Probably going to find all kinds of other crazy things are here. Why is it taking so long to search the web? Convincing, not very convincing. I don't think it looks much like that.
No, not convincing.
looks more like a willow than wisteria.
Yes, it does look more like a willow. What does that look like? I mean, it's very strange that we can't immediately associate because it has an organic look to it, but yet it doesn't sort of. We don't know what. I mean, I think that the sort of I mean, the best I can do is like falling purple flowers, but that's kind of lame.
Then you might as well say the wisteria.
Yes, except that thing really doesn't. I was just thinking the way that it grows on buildings. That's not a. I mean, what kind of plant does this look most like?
Blue ivy.
Is it?
I know that, like, ivy is not blue, but yeah. There's a whole Taylor Swift album being built here.
All right, let's see. If I do web image search for ivy, what am I going to get? I'm going to get some crazy other thing that has nothing to do with. Oh, great! I get individual ivy leaves. Brilliant. Well, let's say, what are they called? Creepers, growers? What the?
Creeping ivy? Is that such a thing?
Yes, but that's the name of a type of plant, isn't it?
Oh no.
I think so.
Just creeper. There's a Minecraft guy that looks like that.
Looks like what? Looks like this?
Yeah, like a green. He's square, or rectangular.
If I say creeper, am I going to get really weird stuff from the web?
You'll get weird stuff from the web.
Yes, don't do that. Don't.
Some
pushing our luck here. It does look like it.
Well, it's green. Honestly, that's its only.
Well, it looks like our Cellular Automata too.
Well, that's right. That's because it's a pixelated universe, which is.
And it's green and has eyes.
Okay, so hanging dreams, attack of the mold from outer space, emerald creeper, family tree of an electron. Somebody suggests. Okay, somebody's suggesting wisteria cascade that I search for. Let's try that. Oops. That's a problem. My mouse just stopped working. Oh dear. Let's see what happens now. It's very odd. Oh, maybe it's still working. Oh yeah. Okay. All right. Wisteria cascade. I think we're not going to get through all of our NFTs. You know, making art is hard. Okay, so I'm not quite as crazy as might have previously been thought. I mean, that's, well, okay, I admit it's not very similar, but it's at least not totally different.
Well, they're showing all the flowers blooming, right? Like, if they weren't blooming, then I think you'd be closer. You know? Because then it'd be all green, right?
Alien flora, someone is suggesting. Yeah, you know, that's kind of that's doesn't quite make it for me there, because it's kind of like RBS suggesting creepers from digital automata. Let's see. I think creepers is potential. What does creeper mean? Do I want to ask that question? I mean, doesn't that mean something for a plant? Doesn't that have a
Creeper is also something that you use to work under your car.
Plant, such as ivy or periwinkle, that grows by creeping. Okay. Any of various small insectivorous birds in the northern hemisphere that climb up a tree trunk, supporting themselves on stiff tail feathers and their feet.
Okay, I have to vote for periwinkle, just out of the sheer oddity of the name.
Oh, but like I think it. Huh? Can you try with movie data? Because I think there's a horror movie called sci-fi movie.
I think there.
Oh, sure.
I'm sure there's a.
And there's many, but there's one old.
That was extreme. Look at, oh, that's a color. Yeah, great. Well, let's see. Difficult. It's fascinating. Which ones are difficult and which ones are not? I mean, it's kind of. I really do like this. What's that?
I'm really going for periwinkle because I want to be like periwinkle.
What is the periwinkle tea? Well, is it? So, are you suggesting creeping periwinkle, perhaps?
Yeah, maybe.
Let's see whether creeping periwinkle has any resonance with anything. Let's see what that.
I think in the movie Snatch, Brad Pitt's character, when he's batting somebody else, he bats about some periwinkle, like periwinkle blue trailer or something.
Well, I'm not seeing the periwinkle is a good color. I agree. Well, all right. Tentatively, periwinkle creeper. I don't like it. I don't like it.
Okay. I'm putting that name in reserve. I'm like writing it down.
Okay, let's write it down. All right, let's keep going. So this is like, functions in Wolfram language. Sometimes there's a function that has the functionality is very interesting, but we just can't make up a name for it, and then nobody knows. But here we've got the thing is a thing without its name, so to speak. The thing is a thing, even though we have no name for it, even though we have no word that describes it. And this type of pattern, to me, as a 4-decade veteran of the computational universe, to me, this is a class 4 cellular automaton pattern. But that's just a nerd name for it, so to speak.
Class 4 creeper.
No, but they're all class 4 things are creepers. So that doesn't really tell us something. All right, we're gonna take a look at some more here, and we've got 2 more there, and we're gonna look at just pick up this again, and we could look in a different space, slightly different space. Do we want to do that? We could. No, let's go on and do the same space. I think this is going to be today's thing is going to be the 5-color totalistic cellular automata are the thing for today. All right, let's go ahead and look at this. That one's going to be interesting, I think. High hopes for that one. I actually have some hopes for that one too. And that one I have reasonable hopes for. That one, maybe, but probably not. Look at that one. So close, yet so dead.
Why is that one dead? Oh,
it's yellow.
Yes. Look, I'm sorry.
Once it's uniform, it's ended. That one has possibilities. But you just have no idea how long it's going to go on. That one has considerable possibilities. That one might be nice there. That might be nice.
Did you have any particular day where you found a bunch of
June 1st, 1980, I found Rule 30. I found Rule 30. June 1st, 1984 was the first time I saw Rule 30 printed out from a high resolution laser printer, which made it really much more obvious what it was doing. But I've looked at. You see, it's not just. Not just cellular automata. You can look at. I've done identity parades of many different kinds of things. Like I found the world's simplest universal Turing machine by doing basically this kind of thing. Okay, let's take a look at those. Better process here for. See, I think people. I don't know the process. You usually don't get to see art getting made unless it's some kind of real-time painting type thing. Let's see. Okay, go. That one's kind of interesting. It's different, unusual.
Well, I think unusual counts.
It does. Yes, it does. It's like finding a diamond in the rough, so to speak. It's unusual to find something like that, in a bunch of mud or something to find. Okay, that's interesting. Right. I think that one might. See, I think that texture. It's just not. It's going to look a little better when its wings are cut off. And some
it's also because of color too. I think it's kind of solid red.
Yeah. Oh, that one is actually more interesting than I thought.
Wow, that one. Like you already picked out that one. So
yeah.
Big green one.
This one, yeah, I like this one.
Yeah.
It's kind of a green circuit.
Or like a Christmas tree. With inverted colors.
Is that one going to be interesting? I think that one is really exciting. All right, so we got 2 from this bunch. And let's go ahead. Those. And do our little thing making these. To streamline this a bunch a bit. Those. Let's look at these.
Wow.
Yeah, it's
That is really spectacular. All right.
Yeah, I like it. Gosh, now we gotta name these. Is the one on the left? I think this one is interesting. I think this one is unusual. All right, so we got those 2. We got to name those. We've got. Let's see, how many do we have in the hopper here? We have. We are looking for 10 total. So we have managed to get. We have 4, 5 here, and we already did 1, right? Did we do 1 or did we do 2?
We did 2. It's with this.
Okay, all right. Let's just do one more iteration here before we. I wonder whether we have an obvious name for either of these.
The blue, the one you just scrolled past, it looks like Elsa from Frozen.
A what?
Like Elsa from Frozen. The Disney movie.
I also saw
I know the Disney movie Frozen. Yes, I'm not culturally that disconnected. I don't see Elsa particularly.
But it's
I guess
really
you see.
cool because I also saw an ice queen, like at the same time.
Yeah,
We're 2 different people.
Well, I can see that. I suppose. I have to say, and it's probably a sign of. It's probably one of these things that is telling one something terrible about us, about different humans. Some people see faces in things more than other people see faces in things. And I'm a particularly bad recognizer of human faces. Like I recognize names pretty well, quite well, but when I see people's faces, I don't recognize them often. And okay, this is trivia story here, but I happened to mention this once to Oliver Sacks, who's a well-known kind of psychological type person. He was like, oh yeah, he said he was the same way, and that he'd sort of tracked this all down, and it was the fusiform gyrus, which is this small region in the brain that is responsible for face recognition, and you end up with this kind of face blindness if that is not as effective as it might be. But I was convinced myself years ago that maybe I just used up all the storage in my fusiform gyrus, storing cellular automata patterns, and because there are lots of cellular automata where I know that's a rule 45, that's a rule 73, and things like that, and maybe that just burnt up all the storage that would otherwise be for faces that I might have had. Anyway, just one of those silly things. But I do agree there is sort of a face to be seen here. Yeah, I could just about see the ice cream concept here. All right, and what about this one here? This one here, first.
That looks like a Star Destroyer from Star Wars. Try with image search.
It also seems like it's circuit, like a cut circuit board.
Yes, I thought circuit board. I like green circuit board.
I'm not a fan of green circuit board, though.
Maybe just circuit board. Like, we can see it's green.
Well, yes, okay, fair enough. That's a okay, good point. But you see, it's not just an ordinary circuit board. It's more like an
Creepy.
well, organic circuit board.
That's a nice contradiction in a way.
It is, right. Growing circuit board, organic.
Self-evolving.
You know, for some reason, I kind of like iced cream rather than ice. For some reason. Maybe too strange. Okay, but let's keep going. Let's do one more. As you can tell, I find it more fun. You see, this naming is hard work. It's more. All right, let's do this another little. What I always it's kind of there's a sort of cellular automaton FOMO. You look at all these things and you say, what if I missed something? Because that might be interesting. Something like that. That's promising too.
Red and gray one.
This one here, it's going to turn to mush. And that one might conceivably turn into something. It really depends whether those tentacles. That one might be interesting. Probably be mush. I can't be sure. That one is going to be very simple. This one might be interesting. Probably will turn to mush. That one might be interesting. That one again might be interesting. That one is quite promising, he says. And as I say, the computational animals are always smarter than you are. It's going to turn out to be the dullest. You know, again, because you can't predict, isn't it? That a copy of a really small
Oh, that one. I wish I would really just select it. Yeah.
Okay.
Like all creatures that grow, they just disappoint you.
Well, it depends. Sometimes they do very, very. No, sometimes they don't. And this is the problem. This is kind of like, you know, it's like searching for talent, and you know, if you pick the talent young, it's hard to tell what will happen. It takes experience to try and tell what will happen, and so it is here. This you know, if you pick the cellular automaton young, you know, will it turn into? I suppose it's like selecting all kinds of creatures. You know, is this going to turn into the most winningest cat for the cat shows or not?
It had to be a cat, huh?
I don't know. I don't think they have frog shows.
I noticed that we lean a lot toward like the green ones. This is like the third batch.
Oh, that's a nice one.
So the other thing that struck me when you were talking about CAs are that like we're just programmed to like these, like the patterns. I mean, it's like I see so many different similar like the color and pattern selections and fabrics and boutiques and other things just across different cultures that I would never. I don't know. It's curious.
Yes. Well, as I say, it is, I think, what's happening is that these systems kind of capture the essence of what, there's something in nature that makes it produce complicated behavior. And, we are basically sampling that in what we're doing here. Okay, we've got several nice ones. That one, I think, is a nice one. Mm-hmm. But that's kind of like a cityscape.
Looks a little bit like Peruvian also. Hey, Christian can say something like from Mayan pyramids. I don't know. I've never been there.
This one is kind of fun for having quite a lot of structure in it. I like that one. It just has a nice mixture of kind of this one. And this one, I think that's going to look pretty decent when it's on that card. All right, let's see. We've probably got enough here, so let's go ahead and let's make our previews, and then we're going to name them, and then we're going to mint them. And then we're going to take questions and comments, and I have to say, at least one of the things about my life is I get to do a diversity of things. This is not picking and naming cellular automata patterns and live minting them. It's just kind of like, okay, let's take that one looked really quite nice. I quite like that one. Quite nice.
The other thing that's striking, but I guess people watching wouldn't have realized, is how things have evolved and just in like working on this stuff with the guys at IOHK, guys and girls at IOHK, men and women at IOHK. Because it's just like, it's been fascinating, but now this is like, it's just really cool.
Well, it's that one. I don't know why does it? I mean, the code is making it not do its. What do you think? I think this one is quite interesting, but it's kind of a shame. I don't know whether it would look better if it had its stripes go all the way out to the edge. We could change the code so it does that.
It looks a lot like an Empire State Building.
Yes. Building with elevators or something. Okay, I'm not sure if that guy makes it there.
Which?
The blue one. And that red one actually is reminiscent of ones I've seen before, which I've really liked before, but I have to say it's not doing it as well for me in this case.
It looks like jewelry on one of those like red velvet cushions that they have in castles.
There's also something like very Persian to it.
Which one? Somebody is suggesting Rorschach's dream. Yeah, that's amusing. That's some. Sometimes we can get. Okay, so this. This one
kind of looks like Escher, something like Escher would row. I see like your perspective of the city from above.
Yeah, I think this is
going down.
that one, I think that one should be called Rowan City. Oops. And then, does this one even make it?
I don't know. It's not as inspiring, especially when it's
not that exciting. All right, it's not that exciting. Now that one is a bit similar. I mean, most of it is yellow.
But there was one that kind of looked like, almost like a fluid kind of pattern, just like more so than other ones. If you scroll by the yellow one that's on top of it.
This one? I think that one was the one we were okay. But this is all right, so we're picking out only some fraction of these. So let's pick out which ones we think are interesting. I think we're going to keep that one. What about this one? I kind of like this one. So let's pick. It's basically everything except that second one. So let's get rid of the second one there. We should. All right. I think we've got a good collection here. So let's go ahead and start. Stick with a few more names. Actually, I would prefer Living City. This one. Are these like? They look very organic, but I don't know how we name them. And this, to me, this one. What I find interesting with this one is that it every so often has one of these kind of vertical pieces. It's not my time to some chocolate to help me think better. Let's see. Plant with elevators. You guys know how that is.
Because I always want to say things like repeating, but yes, of course.
All right, I'm really having a hard time with these. I've seen these for so many years, things a bit like this, and
I'm really getting like a Persian carpet vibe.
I was thinking about carpets, yeah.
Because like it's very, in many former Soviet countries, a lot of people have at home those carpets. The time costed a lot, but you would spend money on those because otherwise your money would inflate and they would not be worth anything the next day. So like my grandparents, my great grandparents, everybody got this sort of carpets in their house. So I just cannot clear the carpet vibe out of my head.
So Victoria, forget cryptocurrency. The real thing to use as a transfer of value is carpets.
It was like for a lot of those, like Mongolian cultures, the carpets were very valuable.
Yeah, well, it's okay. So, maybe there's a carpet. I also saw a carpet there. I mean, something like. I don't know whether it's living carpet.
Persian cat's favorite carpet. That way you have a cat in there.
don't see a cat on that.
No, but you put it on the carpet.
You put the cat on the carpet.
And then you don't have the carpet.
The cat scratch the carpet, and then the carpet has.
Yeah, it kind of has like cat claw marks, sort of. Yeah.
Carpet currency. Magic carpet and carpet currency.
Magic carpet. Nice. Like Aladdin.
I like carpet currency. I think that's funny. I think that's I think living carpet currency. Okay, what about this one here? This one here is like I mean, somehow this has a certain marching robot type look to it.
Or like a Thai temple sort of thing.
It is, but it also has a certain, the arms.
Diamond robot.
A what?
A diamond robot.
Well, I was thinking it was kind of like, if we think about it in terms of a building, I wonder what the image I looked for was about this one.
Or maybe more of like Chrysler building than Empire State, not very good in skyscrapers.
And then we go to cementing here. See, unfortunately, one of the things that I'm realizing, a jungle gym, structural member.
A jungle gym is like perfect.
You think?
Like, we would have never came up with that ourselves. I think we can trust the machine on this one.
Yeah. Okay, fair enough. All right. So let's go ahead and mint these. All right, let's go back up here. We still have that one unnamed one. Let's which we were just going crazy with.
And Steve, that last one, you can set the steps to fill it out, fill out the width.
Oh, how do I do that? I say
chat. Yeah, so like 450 by negative 300, 300.
Right. Let's just see what that looks like if we do that. What's this one called? What is this thing called? It's about I think jungle gym is quite fitting for that. Yeah, okay. Good idea. Okay, all right. Let's go back. So we still have one thing that was undetermined. Which I was.
John suggested willow wind for that one.
Okay, so where was it? This one further back. Right. Yes, it's this one here.
Willow wind sounds great.
Willow wind. Where's the wind? It seems very symmetrical.
Right, but it's going right through it. It's the background. It's the sky.
Spanish moss.
What about willow drops? It has this kind of
Willow in the rain.
willow streaks.
What about bots?
Willow bots. What?
Yeah.
You mean bots as in?
Oh, you're gonna laugh. That old video game on Atari where the little bots are like coming down at you and you have to shoot them all.
There are lots of other meanings of the term bot.
Yes, understood.
Half our world is made of bots by now, even more soon.
It could be anthill.
I think I like the willow concept because the willow does seem to have come up multiple times. But we kind of need to capture. And by the way, yeah, I mean, so. What about something like streaking willow? Is that thought to be too? As in,
weeping willow. Is that plant? Weeping willow. Weeping poetic.
That is a nice poetic twist.
Which falling willow?
Weeping willow.
Yeah, but that's an
actual tree.
Mm-hmm. Yeah.
But you could use the poetic license. It's weeping. It's crying. It's a crying willow.
Well, that's not bad. All right. I just feel like the weeping thing is because it's an actual type of plant. What's another term? How about raining willow? See, I'm not getting. I mean, I kind of like falling willow on the grounds that maybe I'm reminded of sort of what is it, falling water or something. What is that?
What about willow tears?
No, because it's too sad.
There are sad.
I think its general sentiment is positive, But is there something wrong? I mean, streaking. It's kind of like streaking forward. These are like it's
Wolfram willow.
What's it?
Wolfram willow.
Oh, actually, Satara suggests infinite willow.
That's nice.
That's pretty good. I know. Yeah. That's our one.
Yeah.
I like it. Okay. Let us mint. All right, where were we? We had. What was the first? That was the first unminted. Was that one? Okay. All right. So we need to go ahead and mint the infinite willow. I like that. That's good. That's good. Nice. Okay. Here goes. One infinite willow coming right up. I have to not misspell it. I have to not get its code number wrong. Otherwise, we commit to the blockchain forever. Something completely wrong, which we do not want to do. Number 3. there really has to be some kind of. All right, there we have it. Okay. One infinite willow. Now, should I have been sending these to a data pen?
No, I'm tracking all that from the addresses. Each NFT has its own address.
Okay. Worry about that. It would be really sad to have these go out there, and then it's like, it reminds me of someone I know who launched a CubeSat satellite and lost the satellite. Apparently that's not as uncommon as you think.
What was the satellite supposed to do? Like other than
small research satellite.
So did they lose their research too?
Well, I mean, I assume they couldn't do their research because they lost their satellite. You're going to make me tell other crazy stories, like the person I knew who sadly, their PhD project had to do with a neutrino detector that was in the deep ocean near Hawaii, and the thing was being trailed from a ship, the cable broke, and the thing fell to the floor of the ocean. And it was found by some kind of sonar, but it's like 4 miles deep or something.
Right.
And I don't think anybody went to fetch it. That's in the why I didn't finish my PhD thesis. That's definitely one of the better stories. All right, are we happy with the organic power tie? I kind of like the organic power tie.
Love the organic power tie.
Okay, NFT number 4, the organic power tie, is coming right up. Good to go? Yep. Here it goes. And number 4 is minted. Okay.
You need a sound effect.
I know we need a sound effect. I said that. We need we're gonna have that. Next time we're gonna have this function have I was going to say a sting in its tail, but I mean okay, here we go. Correct. 1, 2, 0. Yep. Okay, good to go. And nice. Okay. All right. How many have we done? We've done 5. So we're going to go ahead and let's do the rest of the ones we have here, and I think we're going to call it a day. These are nice. These are looking nice. I'm very happy with these. So the first one here, I'm not very happy with the term. So let's see. What are plant circuits?
Maybe like algae circuit board.
What circuit board?
Algae. Like the
Algae. Oh.
Yeah.
Circuit chip.
About seaweed circuit.
That has a nice rhythm to it.
Yeah. let's start here. Let's see one circuit.
Number 6.
Yeah, it's number 6.
Oh. Actually, I would prefer, rather than sealing circuit, circuit sealant. Is that number 6?
Yes.
We have a suggestion here. Is my sound connected? Let's see. Okay, number 6 there. Let me see whether our
Did
that come through?
For an NFT.
That's amazing.
Let's try that again. It's a little odd, but it's interesting.
I expected it to be more like, ah.
Yeah, I was thinking it would be more like a chink. You know, it's a no, that sounds too currency-like. But you know, more like a ta-da.
Well, we should record our own sound. It'd be funny to take yours and change the frequency, so it's your voice saying nah.
All right, okay. Just because we all these things are. Ta-da! That must be the ta-da. That's the ah sound. Okay, so let's try audio pitch shift, right? Is it pitch shift? Do we want to speed it up?
Try with pitch shift.
Any opinion by how much? What's the unit? Ratio, frequency ratio. Let's try 2.5.
Amazing. Terrifying. Sounds like a train.
What's that? Could be worse. I think you need a more somehow you just have to try it.
That's in the cartoon territory.
Okay, let's do it. Try this. No.
Yikes.
Let's just try back to the 2. No.
Yes. That's great.
It's a certain.
That's really something like Looney Tunes to it.
Can you see what 0.5 sounds like? Darth Vader.
That's
that sounds like the Iron Giant.
Yeah,
that's pretty good. Too. I prefer that higher pitch one.
Yeah, it has a more serious motif to it. I'm sure we can do something else with them. Who knows how to do another audio effect here? We've got
maybe audio reverb to add a full. We can make it fix.
Yeah, we have lots of effects, but I'm just looking at audio processing.
fade time stretch.
Well, it's a speech synthesize of Tada.
Yes, we could actually, and then we could do. But what is audio spectral map? I see. That does that has some that can actually modify the function. Jesse, of course, has a much better scheme. Let's see what does Jesse. Whoops. Go back to submitting here. Okay, so this is the audio. We take the audio, which was on line 101. And I'm trusting Jesse here. This is. I see. So that's looking at, that's mapping it across multiple. That's a chord of the shifted thing. That's kind of interesting. Well, anyway, clearly something can be made of this. All right, let's keep going. We were at the iced queen. Yeah, that was a major chord, right? Because it's minus that's minus 4 semitones. Is that in fact? Wait a minute. Minus 4 semitones to 0 is 5 semitones. So plus 3. Is that right? Anyway, okay, we are on the. You know, for some reason I'm. It reminds me of ice crystals. This one.
Crystal.
Yeah, that's not bad. I prefer that one. Crystal Queen seems good for this. All right, that is that second one there. That's number 7. Is it good? Good to go?
You're playing some.
Okay, let's just do that. That's
That may become a requirement.
It even sounds a little like you, John.
Oh.
okay. Let's see. We've got this, and now we have, I think. Okay, so we have all these to do. All right, so this one. You know, actually, I want to change that one. That one, okay, let's do that first one, but I think it should be called Plant City. Plant City. And that's number 8, right? Am I correct? Good to go,
Yes.
guys? Okay, here it comes.
this, we're going to go. Okay, so now we've got the second one, the living carpet currency. And we've got, should I just put this down? And the second one here. What would happen if I tried to do it on this? It would just fail if I tried to do it on slot 8. Right?
It will probably not fail, but...
Okay, are we happy with this living carpet currency? Just 1 second here. For some reason, non-fungible top carpet. That's an interesting suggestion. What about just currency carpet? I mean, it's a currents. It's a current. It's a flowing currents.
Carpet of currency.
Daniel is suggesting current-C. Current-C carpet. Jabin is suggesting crypto carpet. Crypto carpet is kind of bizarre.
But so is everything in this process. So.
But also everything is crypto in this process.
Although we haven't had any cryptos yet. Joseph is suggesting Cardano's carpet. I wonder what, the original Guglielmo Cardano, or whoever, Girolamo Cardano, that's right. I can never remember, why can I never remember his first name? I wonder if he had Persian carpets. I bet he did. He lived in, he lived in Italy. Where was he? Was he in Venice? Or was he somewhere? No, he was in, maybe, I think he moved around. Maybe Florence, Pisa, those kinds of places. He was a person of all trades. Medical doctor, astrologer, mathematician most famously, coming up with both, to some extent, both complex numbers and negative numbers, and solving cubic. And he also supposedly famously predicted the day of his own death.
He also had a cipher.
Did he have a cipher? Did he make a cipher? That must have been a thing people did back then quite a bit.
Well, one famous one is sort of like a steganography example. You would take a book, then you would have a card with holes on it, and the person has a book and a card would put the card, and in the holes you would read, the actual text.
Oh, that's
cool. From not a book, from a letter, like a filter. I think it's called Cardano Wheel.
And he had no idea that in the time in the future that the word card in English, a language still in development at that time, so a Cardano grill would be people would understand that was something to do with cards later on. Never mind. I'm being a little silly about this. Is the card Dano? Okay. Let's. Okay. We're back on carpets here, and how about for this one? Since we're punning here, this how about something like the current sea carpet? This is a sign that we're getting late in this process, and we're getting, the names get punchier and punchier. I don't see any response to the current sea carpet as being as
I like it better with a dash.
It's leaving everybody else absolutely silent.
I thought you meant C as in like just another capital C.
No. I mean
I get it.
If we get weirdly poetic with it, putting a / between current and C.
I suppose the C carpet would have a dash, not the current C.
Well, but the whole point is it's a currency carpet. Oh my gosh, these class 4 cellular automata, oh my gosh. It's not a woven carpet, it's a grown carpet. I don't know, guys. I don't know. I need help here.
What about emerging? Something emerging. Emerged.
The carpet of a million computations.
I mean, you could probably computationally